In the first 4 questions of the Chapter 6 homework, you saw how atoms can gain or lose electrons so that all their electrons will be paired. But when atoms gain electrons, they're gaining negative charge. And when atoms lose electrons, they're losing negative charge. So once their electrons are paired, these atoms are not neutral overall anymore. Instead, they have an overall charge. And an atom that has a charge is called an ion. So by gaining or losing electrons, atoms become ions. Now there's a pattern for what type of ions atoms become, because there's a pattern for how many electrons elements gain or lose, depending on what column they're in. So remember that anything in column 1, this column on the left, anything in column 1A, I'll just draw a symbol for that, would have just an X because it could be any of those, would have one valence electron because it's in group 1A, so we can draw that 1 there. And we saw in questions 1 through 4 in this homework set that the easiest way to get rid of all of its unpaired electrons is for that to lose that 1 electron. Now lose, if you're going to say lose in math, you would say minus, and an electron has a negative charge, so overall, you're minusing a 1 minus, you would have a plus 1 charge. Plus 1 charge. So anything in column 1A, when it becomes an ion, will have a plus 1 charge. For example, lithium would have a plus 1 charge. Sodium would have a plus 1 charge. Potassium would have a plus 1 charge because all of them would lose 1 electron in order to have all of their electrons paired. And by losing an electron, it loses a negative charge. Minusing a minus is a positive. So anything in that column will have a plus 1 charge. How about column 2A? Well, if we were going to draw a general sort of Lewis structure for anything in that column, we could draw the X, that's standing for whichever element we choose. And because this is column 2A, group 2A, each of these are going to have 2 valence electrons. And we saw in questions 1 through 4 for this that the easiest way for an atom that has 2 electrons to get rid of all its unpaired electrons is to lose those 2 electrons. If it lost those 2, then the atom would have all of its electrons paired. It wouldn't have any unpaired electrons. So now let's translate that sentence into math. Lose is minus, and 2 electrons, each electron has a negative charge. If you have 2 of them, that's a negative 2 charge. So you're losing minus 2. In other words, you'd have a plus 2 charge. Anything in column 2A will have a plus 2 charge when it becomes an ion. So for example, beryllium will have a plus 2 charge. Magnesium will have a plus 2 charge. And remember, the charges are written in the top right of the symbol. Okay. Now, let's go to 3A. We can draw the symbol there, so this would have that capital X, because it could be any of those elements in this column. And because it's in group 3A, it's going to have 3 valence electrons. So 1, 2, 3. And the way that any of those elements can have all of its electrons paired, have no unpaired electrons, is to lose those 3 electrons. So that would lose 3 electrons. Now if you were to translate that into math, lose would be minus 3 electrons. Each electron has a minus 1 charge. If you have 3 of them, that's minus 3. Minus 3 is plus 3. So when anything in the column 3A becomes an ion, it will have a plus 3 charge. So for example, aluminum, or let's say boron, when boron becomes an ion, it will have a 3 plus charge, or a plus 3 charge. You could put the plus sign before or after the number, when it's in the top right of the symbol, both are correct and acceptable. So you'd have Al, when that becomes an ion, you could have a +3 charge. And so that would be for column 3A. Now for column 4A, that's an interesting case. If you draw the symbol here, because it's in group, everything here is in group 4A, you'd have 1, 2, 3, 4. Now this can either lose those 4 electrons or gain 4 more electrons. So it could either lose the orange ones and have no unpaired electrons, or gain 4 more and have all of its electrons paired. So it could either lose or gain 4 electrons. And so you could either lose 4, now the way you'd say that in math is you'd lose 4 electrons, each electron has a -1 charge, so 4 would have -4, or you could gain, the way you'd say gain in math is plus, you could gain 4 electrons, each electron has a -1 charge, so if you gained 4, that would be -4. So you could get 2 possible charges on anything in this group, this column. You could have a +4 minus negative is a positive, or you could have -4. So anything in group 4A has a plus or minus 4 charge. Okay, let's try 5A. So 5A, anything, let's just draw a general symbol here, and again, this X doesn't stand for any specific symbol, it's just standing for anything in this column, the column we're talking about. So because everything in this column is in group 5A, they all have 5 valence electrons. So we can put these around our symbol like we learned how to do in questions 1 through 4. And there we have 5 of them. And the easiest way for these elements to get everything paired is to gain 3 electrons. So they gain 3 electrons. Another thing it could have done was lose 5, but you always go with the lower number. It's easier to gain 3 electrons than to lose 5 electrons. The way you can translate gain 3 electrons into math is gain is plus, and electrons, each electron has a -1 charge. If you have 3, that's a -3 charge. So that overall charge would be -3. And so anything in this column, 5A, when it becomes an ion, will have a -3 charge. For example, nitrogen would have a -3 charge. Or phosphorus would have a -3 charge. Anything in that column, when it becomes an ion, when it gets a charge, it would get a -3 charge. Okay, let's think about 6A. So we'd have our symbol there. Because everything here is in group 6A, we have 1, 2, 3, 4, 5, 6 electrons, valence electrons. And so all these need to do is to gain 2 in order to have all paired electrons. So they need to gain 2 electrons. Gain is plus 2 electrons. Each electron has a -1 charge, so 2 would have a -2. So when these become ions, they would have a -2 charge. So for example, when oxygen is an ion, it will have a -2 charge. When sulfur is an ion, or selenium, or tellurium, all of those would have a -2 charge. All right, last but not least, let's draw the symbol for group 7A. So everything in this group, 7A, and this group are called the halogens, would have 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Notice that I put 1 on each side before I start pairing them up. And to get all of these paired, you would just need to add 1. In other words, anything in group 7A just needs to gain 1 electron to have everything paired. Let's translate that into math. Gain would be a plus. One electron has a -1 charge, so the overall charge on these would be -1. Okay, so when anything in this row becomes an ion, whenever anything in this row takes on a charge, it'll have a -1 charge. So for example, fluorine would have a -1 charge. Chlorine, when it becomes an ion, would take on a -1 charge, and so on. Okay, so that's kind of a lengthy explanation, but now that we've done all of that work, the problem is going to be really, really simple and straightforward. We just need to remember this row here. So we'll go down and we'll say, okay, they're asking to write the symbol for the ion of chlorine. Well, first write the symbol, then where is chlorine? Chlorine is in group 7A. Everything in group 7A has a -1 charge. So this chlorine will have a -1 charge, and that's the symbol for the ion of chlorine. How about cesium? Cesium is in the bottom left of the periodic table. It's right here. It is in group 1A. So we can write CS for cesium, and because it's in group 1A, it will have a +1 charge, because everything in group 1A has a +1 charge. So we can write +1. How about nitrogen? Okay, well, nitrogen is sort of in the top right of the periodic table. It's right here. It's in group 5A. So we'll write capital N just to get the symbol there. Because it's in group 5A, it has a -3 charge. Everything in group 5A has a -3 charge. So we can write -3. And that's the symbol for the ion of nitrogen. How about radium? Radium is in the bottom left of the periodic table. You can see it right here. So we can write that symbol down, Ra for radium. Because it's in group 2A, it will have a +2 charge. Everything in group 2A has a +2 charge. So radium will have a +2 charge. Oops, and this should have an A down there. So +2 charge. And so getting those was really straightforward once we had reasoned through this, created this purple row here, the charges that each of these have. So you might memorize those charges. Group +1, +2, +3, minus, ±4, -3, -2, -1. Okay, 7 is the same thing. So let's write the symbol for the ion, that's the atom when it has a charge, for fluorine. Fluorine is a capital F. You can see that it is in the top right in group 7A, so it has a -1 charge. So we can write -1 as the charge in the top right. The charge is always written in the top right of fluorine. And that's the symbol for a fluorine ion. Okay, next one, calcium. Calcium, the symbol is Ca. You can see that that is over here. Oops, that's cesium. Calcium is right here. It's in group 2A, and because it's in group 2A, we know that it has a +2 charge. So we can take that calcium and write a +2 in the top right. How about sodium? Sodium, the symbol is Na, so capital N, lowercase a, and then sodium is in the sort of the top left. Because it's in group 1A, it has a +1 charge. So we can write +1 at the top right of that sodium. Iodine. Iodine, the symbol is capital I. It's in the sort of bottom right of the periodic table. So you'd see it right here. Because that is in group 7A, it would have a -1 charge. So that iodine would have a -1 charge. And so you can see in exercises 6 and 7 how this pattern that we reasoned out of how ions are formed by losing or gaining electrons to give us reliable charges could be really useful in figuring out the charge on so many elements, figuring out what type of ions, charged atoms, they are.